Okay, so we're going to be talking about absolute value equations and how to solve them. So to remind you what an absolute value is, an absolute value, it looks like two vertical lines. So like absolute value of, you can take the absolute value of a number, right? Absolute value of -3. Now, if you remember what absolute value is, absolute value means like the distance a number is away from zero. How far away from zero is this number? So how many units away from zero is -3? It's 3 units away from zero. Because if you think about a number line, there's 0, -1, -2, -3. If we're talking about the absolute value of -3, -3 is right here on the number line. How far away from zero is it? It's 1, 2, 3 steps away from zero. So the absolute value of -3 is 3, right? Absolute value means distance from zero. How far away from zero is this number? So the absolute value of -3 is 3, because -3 is 3 units away from zero. What's the absolute value of 2? Well, here's 2 on the number line. How far away from zero is it? 1, 2 units. So the absolute value of 2 is 2. So the absolute value always takes whatever value is in between the vertical lines and just makes it positive, right? So your absolute value can never equal anything negative. Does that make sense? Because if you were to say absolute value of something equals -1, then you're telling me that that number is -1 units away from zero, and there's no such thing as -1 units away from zero. It's just one. You're either going to take a step away or you're not, right? So absolute value doesn't care which direction you're going. It just takes off the negative. So an absolute value equation is an equation that has an absolute value expression, meaning you got an absolute value and there's a variable inside. So we're going to have stuff like absolute value of x equals, let's do this one real quick. Absolute value of x equals 3. And let's think about what this equation is really asking us. So this equation says, so absolute value means distance away from zero, right? X means there's a number. We don't know what it is yet. There's a number or numbers, right? So absolute value of x means there's a number or numbers whose distance away from zero is equal to 3. Well, we can kind of figure that out, right? Just if we can figure that out without really doing math, we can just, without really doing calculations, we can just say, all right, absolute value means distance away from zero. There's some number whose distance away from zero is 3. So if I go 3 units to the right, that number would work, right? But also if I go 3 units to the left, that number would also work, because the absolute value of -3 is 3, because it's 3 steps away from zero. The absolute value of +3 is also 3, because it's 3 steps away from zero. So anytime you have a variable in your absolute value, you're going to get two solutions, because there's a negative value and a positive value that both have the absolute value equal to 3. So when you're solving this equation, you're actually going to get 2 solutions: x equals 3 and x equals -3. And there's a shorter way to write that. You can just write, instead of writing both of those, you can write x equals ±3. And that means x equals both +3 and -3. It's giving you 2 different solutions here. ±3, positive, or -3 would be those solutions. So you can see when you have an absolute value, you're going to have 2 solutions. one that comes from the negative value being inside the absolute value, and one that comes from a positive value being inside there. So here are some properties about absolute values. Absolute value of any number has to be greater than or equal to 0. Can't have absolute value equal to something negative. It's okay if it's equal to 0. That just means it's 0 units away from 0. So it's on 0. It can be greater than 0. It can be more than 0 units away from 0, but it can't be a negative. You can't have absolute value be less than 0. Can't have a absolute value have a negative value. Here's another one. Absolute value of negative a is equal to the absolute value of positive a. Right? We kind of look at that with 3 and negative 3. They're both 3 units away from 0. Number 3 here, the absolute value of a times b, so absolute value of a product, is equal to the product of the absolute values. So what you might see here, you might see absolute value of like 3x. That means that you can break that apart into absolute value of 3 times absolute value of x, which is 3 times the absolute value of x. So you're able to do, we're giving you rules where you can do a little bit of algebra here. So you can break apart a product, or you can break apart a quotient as long as your denominator is not 0, because you're not allowed to divide by 0. And when we're solving absolute value equations, so this is what like a general absolute value equation might look like, where a, b, and c would all just be numbers and c is not negative. As long as c is not negative, all you do is you take whatever's inside the absolute value, you set it equal to, so that number can either equal c or negative c. Whatever is inside, let me, so whatever is inside the absolute value, if you think about, like if you have an absolute value of something and it equals a number, right? There's only 2 numbers that whatever's in there could equal. It can equal c or it can be negative c. So all we have to do is take the inside, whatever is inside the absolute value, and we're going to write 2 equations. One where it equals that number, and one where it equals the opposite of that number. So whatever is inside the absolute value, you set that equal to the number, and then you get another equation where you set it equal to the negative. If c is a negative number, then it would have no solution. So if you have absolute value of 2x minus 3 equals negative 4, you have an absolute value equal to a negative number. That can't happen, so that is a no solution. So you got to be careful when you have an absolute value equal to a negative number. That tells you no solution. Let's look at some examples. We're going to solve each equation, and we're going to graph the solutions if possible. So for the first one, we got absolute value of x minus 4 equals 6. We have an absolute value equal to a positive number, so that's okay. So that means that we can solve it. Well, the way we solve it is when we have the absolute value by itself, we have absolute value of something equals 6. That tells us whatever is inside of here, there's only 2 options. Either it equals 6 or it equals negative 6, right? Because those are the only 2 numbers. If you take the absolute value, you get 6. So then you just take whatever is inside the absolute value and you write that twice. So x minus 4 equals 6, or x minus 4 equals negative 6. And now you just have 2 equations that you can solve. So x minus 4 equals 6. The x has a minus 4 by it. We want to get rid of the minus 4, so we're going to add 4 to both sides of that equal sign. And we get x equals 6 plus 4 is 10. Then we're going to solve the other equation, and it's going to be the same step. We're also going to add 4 to both sides to get rid of the minus 4 by the x. But this time, we get x equals Negative 6 plus 4 is negative 2. So now it says to graph the solutions if possible. The only way we can graph these is just on a number line, right? So x equals 10 or x equals negative 2. So if I say that I'll say this is 0, pick a 0 spot. I'll say this is 0. And then I'm going to count each one of these as 2. So 2, 4, 6, 8, 10, 12, 14, negative 2, negative 4, negative 6. So then to graph this, you just put a dot where x is negative, or where x is 10, and a dot where x is negative 2. So right here, this is the solution in the graph for part A. So let's take a look at part B. Part B, we've got absolute value of 3x plus 1 equals negative 5. Well, this is that situation. An absolute value can't be equal to anything negative, right? Absolute value is going to be 0 or bigger. So this question has an absolute value set equal to a negative number, and we know that can't happen. So this one has no solution. We can't have absolute value equal to a negative number. Absolute values are always positive or 0. Okay, so we're done with example 1, but I want to point something out before we move on. I want to point out really quick, if you look at this graph down here for part A, where our solutions are, what number is halfway between them? 4 is halfway between them. And then you notice that there's a 4 right there. And then how far from that middle number is each one of these solutions? 2, 4, 6 to the right gives you 10. 2, 4, 6 to the left gives you negative 2. So the distance, so the target or the middle number, so we have a middle number, and then the distance away from the middle number. And it'll always work like this with absolute values. There will always be a middle number, which is right there, shows up right there in the equation, x minus whatever that number is. And then the solutions are going to be the same distance away from that number, and the distance away is right there. So it goes like this. It goes x minus the middle number. Before they called it a hashtag, that was just the pound sign, and it meant number. So I use it for number sometimes. Don't hate me. So absolute value of x minus the middle number equals the distance from the middle number. And this is gonna come in handy later on. There's a type of problem that they give us where we have to come up with an absolute value equation with certain solutions. Okay, so this one will be that we will use this in a couple of examples from now. Okay, so let's look at example 2. Now you might look at example 2 and say, equals -4. Can't have an absolute value equal to a negative number, so this one must be no solution, right? But the absolute value isn't by itself yet. So this equation isn't telling you that an absolute value is equal to a negative number yet. We have to get the absolute value by itself before we can determine if we have no solution or not. So we can't just at first glance be like, oh, haha, equals -4. This is no solution, because look what happens when we go to get the absolute value by itself. We've got absolute value of something -10 equals -4. So when we start off solving absolute value equations that have stuff outside the absolute values, our first goal is to get the absolute value by itself. So first we need to get the absolute value part by itself. So first, get the absolute value by itself. First, we have to isolate the absolute value. Then we'll get our 2 equations, and then we'll do inverse operations to solve the 2 equations. So what we need to do is we need to add 10 to both sides of the equal sign here to get rid of this -10 over here. So then we get absolute value of 3x plus 9 equals, because we got rid of that, -4 plus 10 is 6. So now we can see, now that we got the absolute value by itself, we can see that the absolute value is actually equal to a positive number, so that we can get our 2 equations from that. So every time you get the absolute value by itself, the very next step is to split it into 2 equations. One where it's basically writing the same thing without the absolute value. The inside, 3x plus 9 equals 6. Or the inside would have to equal -6. So 3x plus 9 would equal -6. Notice that I'm not changing the signs of anything that was inside the parentheses. If this was 3x minus 9 inside of there, I would still write 3x minus 9 on both of these. The only sign I'm changing is on what it's equal to. It's either equal to 6 or the opposite, which is -6. So now I have 2 equations that I can solve for. And I will get 2 solutions. So if you look at each one of them, the x has a plus 9 and a times 3. So we're going to do the same inverse operations to both equations because we have the same insides. So we're going to start off by subtracting 9 from both sides of each equation. So on the left side, we get 3x equals 6 minus 9 would be -3. On the right side equation, we get 3x equals -6 minus 9 would be -15. So then we're going to divide both sides by 3 on each equation and get our 2 solutions. Because x is multiplied by 3, so we need to divide by 3. And we get x equals -1 or x equals -5. So one thing, a habit that you should get into, especially with absolute value equations, is to plug back in and just make sure it works, right? So if I just think about plugging this back into the original equation, you don't have to write this out when you do this on your homework, but I would suggest that you at least do it in your head. So 3 times -1, so I'm thinking about plugging in x equals -1 right now to make sure this works. 3 times -1, that's going to make that -3 plus 9. -3 plus 9 is 6, so absolute value of 6. Absolute value of 6 is 6, so 6 minus 10 is -4. So we can see that x equals -1 works as a solution. Then we can also check -5. If I put -5 in for x, if I put a -5 in, the 3 times -5 would be -15. -15 plus 9 would be -6. The absolute value of -6 is +6. 6 minus 10 is -4. So both of our solutions work. So this was just us checking our answers. But when you're doing your homework, you'll be able to just look at the answers to see if you did it right. So the next example, example 3, is going to be one where they're going to give us the 2 solutions, and we have to come up with the absolute value equation that has those 2 solutions. So example 3, in a cheerleading competition, the minimum length of a routine is 4 minutes. The maximum length is 5 minutes. Write an absolute value equation that represents the minimum and maximum lengths. So we want to write an absolute value equation that has 4 and 5 as solutions. So what I'm going to do to start off is just to give myself like a little visual representation. I'm going to, this number line up here, I'm going to put dots that represent 4 and 5. I'm going to spread them out a little bit. I'm going to say this is 3, this is 4, this is 5, 6, 7. So in between, this will be like, that would be 3.5, 4.5, and so on, right? So if I need one solution at 4 and one solution at 5, I'm going to put a dot at 4. I'm going to put a dot at 5. Those are my 2 solutions, right? Then let's remember back here on number 1, we found out when it was x minus 4 equals 6, our middle number was at 4, and our solutions were 6 units in either direction. And so the pattern that we get is x minus the middle number in the print, and that goes in the absolute value. That equals the distance away from the middle number that our solutions are. So when you have, they give you the 2 solutions, all you have to do is figure out what's the middle number and what is the distance away from the middle number. And then just do this. X minus the middle number equals the distance away. So what's our middle number? Halfway between 4 and 5, our middle number is 4.5. And then how far away is each solution? 4.5 plus a half, so would give you 5. 4.5 minus a half would give you 4. So our distance away is 0.5, right? So our equation is just going to be absolute value of x minus the middle number, 4.5, equals the distance away from that middle number that our solutions are, and that distance is 0.5. So this is our absolute value equation, and then I'm just going to show how if we were to solve that, we would get the solutions that we were looking for. Okay, so we have this one, we have our absolute value all by itself already. So we would get two equations. One where the inside equals 0.5, and another where the inside would equal negative 0.5. And the inside was x minus 4.5. And to solve both of these equations, we would do the same. We need to do the same inverse operation. X minus 4.5, the opposite of minus 4.5 is plus. So we're going to add 4.5 to each side of each equation. And then you can see that on the left side, when we 0.5 plus 4.5, we get x equals 5. And on the next equation, negative 0.5 plus 4.5, that's the same as 4.5 minus 0.5, so this is 4. So that just shows us that this was the right equation. X minus the middle number equals the distance away. This lesson is a little bit long. I think there's 6 or 7 examples to go through. So this one we're going to be practicing for a couple days. Okay, here's another concept. If you have, so before we had absolute value of ax plus b equals some number, right? Now we're going to say, well, instead of some number, what if it equals another absolute value expression? Basically, we're just going to do the exact same thing. We're going to do the inside of this equals the inside of that. That's this first equation. Or we're going to do the inside of the first one is equal to the opposite of the second one. So that's how we get this one. And then if you look at it, you can tell that you're going to need to distribute that negative through, right? If there's more than one term over here, you're going to have to distribute that negative. But we only made the right, we only changed the sign on the right side of the equal sign. If we change it on both sides, then we're going to get the same solution. So one where the inside equals the other side positive, one where the inside equals the other side negative. It's basically the same, process, right? The inside of the left equal to the right, the inside of the left equal to the opposite of the right. One where the right side's positive, one where the right side's negative. And then you remember when I said we're going to have to be checking our solutions? Anytime you have absolute values on both sides, you have to check all your solutions to make sure they work. Because sometimes when we have absolute values on both sides, we'll get a solution that doesn't work. We call it an extraneous solution, and we'll go over that too in a little bit. Okay, so here's a couple of equations for us to solve. So first, we'll start with the absolute value of 3x minus 4 is equal to the absolute value of x. And so all we're going to do is the inside of the left equals the right, and then another equation where the inside of the left equals the opposite of the right. So first, I'm going to do the inside of the left, which is 3x minus 4, equals whatever's the inside of the right, which is just x. The other equation is going to be the same inside of the left. So 3x minus 4 equals, now I'm going to do the opposite of what's on the inside on the right. So that would be negative x. And now I've got two equations to solve, and I'll get two solutions, but I have to check them in our original equation to make sure that they both work. Because if one or both of them doesn't work, then we need to throw it out. So let's solve. Let's see, we've got x on both sides. So I'll subtract 3x from both sides. of the equal sign. And that's going to give me 3x minus 3x is 0. So that'll be negative 4 equals x minus 3x will be negative 2x. Then to solve for that, I would need to divide both sides by negative 2. And that would give me a positive 2 equal to x. So one of my solutions is x equals 2. Well, I'll just check that right now and just make sure that works. I'll check it in green over on the side here. So I'm going to check x equals 2. So I'm going to do absolute value of 3 times 2 minus 4 equals absolute value of 2. 3 times 2 is 6. So this is absolute value of 6 minus 4 equal to the absolute value of 2. 6 minus 4 is 2. So absolute value of 2 equals absolute value of 2. That's 2 equals 2. So yeah, that works. That one is, we're happy about this one. This is a good solution. Now let's check the other equation to see what solution we get there. I'll do the same steps. I'll subtract. Yeah, question or stretching? Okay, stretching. Subtract 3x from each side of the equal sign. We get, so we're going to get negative 4 equals negative x minus 3x would be negative 4x. Then to get x by itself, we're going to divide both sides by negative 4. And that gives us negative 4 divided by negative 4 is 1. So we get x equals 1. Okay, so let's check that solution. So then we will be doing 3 times 1 minus 4 equals x is 1. So this is absolute value of 3 minus 4 equals absolute value of 1. 3 minus 4 is negative 1. So absolute value of negative 1 equals absolute value of 1. And these both have an absolute value of 1. So both of those solutions worked for us. So for A, we get 2 solutions. Let's then look at B. Was that too fast? Do you need a little second to? No. Okay, so let's do B. So we've got absolute value of 4x minus 10 equals 2 times the absolute value of 3x plus 1. So on this one, we have to be a little bit careful because so we're still going to do basically the same process, right? We're going to write 2 different equations. One where the inside of the left, well, the inside of the left is going to be the same on both, right? So 4x minus 10 equals 4x minus 10 equals. The first one we're going to put, we're going to do 2 times 3x minus 1. So that means that we're just going to do parentheses for the 3x plus 1. I might have said minus, sorry. But for the next one, we're just going to put a negative. So negative 2 times 3x plus 1. And when we only need to put the negative in front of the 2 because the negative 2 is going to get distributed through there. So we're multiplying the whole side by a negative. Okay, so then let's do this. We need to distribute on both sides. So we're going to get 4x minus 10 equals 2 times 3x, 6x plus 2. Or 4x minus 10 equals, that's going to give us negative 6x minus 2. Let's see. On the first equation, I have positive 6x on the right side, 4x on the left side. I'm going to subtract 4x from both sides. of the equal sign, because that'll leave my, these will go away and I'll have positive 2x left over on this side. So then I would have negative 10 equals 6x minus 4x is 2x plus 2. I'll just finish solving this one. I'm going to subtract 2 from both sides because I'm trying to get my x by itself, so I need to get rid of the plus 2 and the times 2. So then I get negative 12 equals 2x. Divide both sides by 2. And I'm going to get x equals negative 6. Okay, now let's solve this other equation. Instead of subtracting 4x from both sides, I'm going to get rid of my negative 6x by adding 6x to both sides. So then I get 10x minus 10 equals negative 2. Then I'm going to add 10 to both sides. That gives me 10x equals negative 2 plus 10 is 8. Then I'm going to divide both sides by 10. And I'm going to get x equals 8 over 10, which is 4/5. Or you can write that as 0.8. Now I'm just going to check those and make sure they both work. So I'm going to check them in the original equation. So let's see. 4 times negative 6 minus 10 equals 2 times the absolute value of 3 times negative 6 plus 1. 4 times negative 6, that would be negative 24. This 3 times negative 6, that's negative 18. So then over here, we're going to get absolute value of negative 34 equals 2 times absolute value of negative 17. And you can see that this is going to work. Absolute value of negative 34 is 34. Does that equal 2 times 17? Yes. So x equals negative 6 works. Now let's check 0.8. So 4 times 0.8 minus 10 equals 2 times absolute value of 3 times 0.8 plus 1. So 4 times 8 is 32. So this is 3.2 minus 10. 3 times 8 is 24. So this is 2.4 plus 1. 3.2 minus 10, that's going to be negative 6.8. 2.4 plus 1 is 3.4. Absolute value of negative 6.8 is 6.8. That is going to be equal to 2 times 3.4. So that one works out too. So both solutions work. For example, 4. And I got to kind of push through to at least get one more before we lose the rest of this class time. This one, let's check, we'll solve this and check for an extraneous solution, right? So we've got absolute value equal to 4x. The absolute value is by itself, so we can just say the inside equals 4x, or the inside equals negative 4x. So the inside was 2x plus 12. Okay, to solve the first equation, I have 4x on the right side, which is more than 2x. So I'm going to subtract 2x from both sides. That's going to give me 12 equals 4x minus 2x, 2x. So then when I divide both sides by 2 to get x by itself, I'm going to get x equals 6 as one solution. And then I'll do this. I'll do also subtract 2x from both sides on this one. So then I get 12 equals negative 4x minus 2x will be negative 6x. Then divide both sides by negative 6. And we get x equals negative 2. So now we're going to check those solutions and make sure. Now notice that we have when you really need to check extraneous solutions is when you have an x that's not in the absolute value, because you'll hopefully you'll see why that can cause a problem for us. So I'll do this in blue. So I'm going to check x equals 6. So 2 times 6 plus 12, that's in the absolute value, equals 4 times 6. Well, 2 times 6 is 12, so this is absolute value of 12 plus 12 equals 4 times 6 is 24. 12 plus 12 is 24. Absolute value 24 is 24, so this one works. So x equals 6 works for us. Now let's check x equals negative 2. So absolute value of 2 times negative 2 plus 12 equals 4 times negative 2. So 2 times negative 2, that's negative 4. So we're doing negative 4 plus 12 inside the absolute value. And then 4 times negative 2 is negative 8. Hopefully you already see a problem. You have an absolute value equal to a negative number. But we can simplify. This is absolute value of 8 equals negative 8. And it wants to say 8 equals negative 8. But 8 does not equal negative 8. So we say this one, we throw it out. This is not a solution. This is an extraneous solution. But say you're doing this question on a test or a quiz, and you forget to do everything to the right of that blue line. Even though that's an extraneous solution, you didn't find it and show that it was extraneous, so you wouldn't get full credit for that. If you only remember to find one solution, you're only going to get half credit. You have to check for the other solution, and if it's extraneous, then exclude it. Okay, we might have time to race through this last one, and hopefully 2 absolute values. Okay, so we're going to do the middle, or the inside of the first equals the second inside. So x plus 5 equals x plus 11. Or x plus 5 equals the opposite of what's over here, x plus 11. So this first one, look what happens when we try to, we got x on both sides. I'm going to subtract x. We end up with 5 equals 11, which it does not. So we don't get a solution from that equation. Let's check the other equation. So this would be negative x minus 11. Now I'm going to add x to both sides to get rid of my negative x. So then I get 2x plus 5 equals negative 11. Subtract 5 from both sides. Then we get 2x equals negative 16. Then when we divide both sides by 2, we are going to get x equals negative 8. And then we just want to check and make sure that works in both. Absolute value of negative 8 plus 5 equals absolute value of negative 8 plus 11. Negative 8 plus 5 is negative 3. Negative 8 plus 11 is 3. Absolute value of negative 3 is 3. So we win. Our solution is x equals negative 8.